So, visual media in astronomy and astrophysics is the theme which I am going to discuss with you very shortly. As you know, up until the 19th century, for the human being, the space was considered as an eternal and non-changing quiet space. But in the 20th century, the humankind began to understand that space is more dynamic. First, we came to know that the space started with the Big Bang. And then with the use of radio wave, X-ray, and infrared rays, we were able to see some part of and phenomena of the universe. And we came to know that all celestial bodies were born and then die. And all of those celestial bodies not only evolve, but are extremely dynamic and full of explosions, as a matter of fact. And those explosions, of course, show a dynamic temporal changes, and one of the typical examples is jets. And space is full of explosions and jets, and that means visual medium is very important for use. Well, we used a lot of photography in the 20th century, but for the 21st century, the visual media is indeed essential for the advancement of our understanding in astronomy and astrophysics. And that is the first message I would like to put across to you. And this is the contents I would like to take you through. First is movies from solar observations, which Dr. Isobe is going to elaborate later on. And for solar system, Voyagers and other spacecrafts are used to capture images close to the celestial bodies. On the other hand, the supercomputer has made such a rapid and mind-boggling involvement. So with the use of computer simulations, we were able to have more insights into the space phenomena. For instance, the galaxy takes about 100 million years for one rotation, but with a computer simulation, we can understand even those phenomena, and that's the theme of Dr. Ebisuzaki's presentation. And today we are able to have movies from cosmic observations, and that's what Dr. Emmert is going to discuss as for the digital universe. With the use of very special polarizing filters, movies captured in such a manner can be presented in 4D, that is 3 dimensions plus a temporal axis. Dr. Ebisuzaki is a pioneer in this regard, and Dr. Emmart as well is going to give us a presentation in that regard. So let me start with the observations of the sun. As you know, this year marks the 400th anniversary of the Galileo's observation with the telescope to the space. And this is the year, the International Year of Astronomy. And many events are taking place around the world in commemoration of this anniversary. We are approaching the end of the year 2009, and in that sense, this symposium is quite timely that we are able to celebrate the end of this important year with this event. And this is the series of sketch by Galileo from June the 2nd, June the 8th, 16th, 13th. He produced and drew such sketches every day, and if you put them together, this is actually a flip cartoon or flip animation. Perhaps this is the very first flip animation or sketches of the astronomy made by a humankind. And thus, we are able to advance the field of science through the use of visual images. So visual images are fun, but at the same time, it helps us advance the knowledge of science. And Galileo were able to understand that sunspots develop day by day in such a manner. And he actually drew and left detailed sketches of the development of the sunspots. Now let us jump toward the present day. This is what we captured in my observatory in Hida. This is the phenomena known as prominence. Prominence is very well visualized at the time of eclipse, but eclipse is such a short phenomena. So we didn't know very much about the prominence in the past, but with such a tool, we can observe the prominence on a routine basis. And thus we can understand the speed of prominence and the intensity of energy. Without a visual image, the solar study is not possible today. And this is showing the biggest solar prominence ever in history. This took place over 50 years ago, and this was captured in the United States. And this have begun to reveal in front of us the real phenomena taking place on the sun. And not only the visible rays, but also we can use X-ray to observe the sun. And this is captured from a X-ray astronomical satellite called Yoko, launched from Japan. And in editing the films, a group of graduate students at Kyoto University did a very good work, and they were presented with the outstanding award for a academic film yesterday. So this is part of what they have produced. With the X-ray, corona can be observed just in front. And you can see that date 1992, May 20th, 21st, and so forth. And this really shows the rotation of the sun as mentioned by Galileo. And so many explosions called flares all around the sun. And all of those stripes show the lines of magnetic forces. And those explosions are caused by the working of the magnetic field, as Dr. Isozaki would tell us later on. And such a phenomena on the sun have exercised such enormous influence upon the Earth and also on the humankind. Now, what about the solar system? This is Jupiter taken from Voyager. As you can see, so many vortices. Rotation speed is 10 hours, so very rapid current, and sandwiched between different moving currents, vortices are produced. And this is a very big red spot continuing over 400 years, and this is a typhoon. And this is a typhoon hitting the Japanese archipelago. And this typhoon image is very similar to the red spot we have seen earlier for the Jupiter. This is one particular instant, and whenever I see this, I really feel that this is so similar to galaxy. This is a Galaxy M51, and as you can compare those photos, you know that you are struck by the great similarity. Just by comparing the still images, we can come to know the basic principle behind all of those different phenomena. Yesterday, in the award ceremony, I was struck by the presence of a festival which was very similar to a local festival, very famous in Japan, called Namahage. Now, for galaxy to rotate once, it takes 200 million years. So we haven't got any video for galaxy's rotation, but with the computer simulation, we can make it visual. This is once again one of the award-winning work by Takeda, Baba, and Saito. And this is called a computer simulation of a galaxy, entitled Dynamic Spiral in the Universe. A wonderful computer simulation indeed. Between the celestial bodies, gravity's work, and this particular film was produced by calculating numerically the level of gravities in between all the stars in the universe. in the galaxy. They used a supercomputer called Grape, which is a computer dedicated for such a purpose. And the computer was made based upon Japanese proprietary technology. So this is a visualization through computer simulation how galaxy rotates. The farther you go from the center, the speed is slower. And all of such a phenomena looks very similar to the vortex we saw for a typhoon. So for their numerical simulations, not just the interstellar motions, but also the supernova phenomena at the end of the life, such numerical simulations were also included. So they employed the state-of-the-art computer simulation for the production of that film. Computer simulation is now used in many application fields, and this is a hydrodynamic simulation by Professor Yabe. This is a very simple one, throwing a log, cylindrical wooden log into the water. And this simulation uses 100 by 100 by 100 lattice spots. And all the simulations concerning the air, water, and the wooden log were included. And this is another computer simulation. And again, an outstanding award was given to this particular simulation. And this is a jet phenomena of the sun taken from the Hinode satellite. In this particular case, magnetohydrodynamic simulation was employed. The computer simulation was able to reproduce exactly the jet phenomena which was captured by this observation satellite, and it really astonished me. Just at the core of a galaxy, an interesting phenomenon called cosmic jet is taking place. And for many years, we didn't know what it was. And we came to more or less suspect that the core is a supermassive black hole. And the black hole absorbs everything. But then why is it possible for a jet to be ejected from a black hole? 20 years ago, I had tackled with that question. And this is my answer. My answer is perhaps the magnetic field is working behind the scene. Here at the center is a black hole, and when the gas goes in, of course it goes like a vortex. And through the interaction with the magnetic field, the lines of magnetic forces are twisted gradually. And because the magnetic field has a repulsive force, it ended up producing a jet from a black hole. And this is how I demonstrated that with the computer simulation. This is the more recent computer simulations done by collaborators at the center of the galaxy. Such a phenomena seems to be taking place. And this is how we can obtain more astrophysics insights by the use of numerical simulation, although the phenomena itself takes so many years to be captured in reality. This is from a Hubble telescope of a protostar. And as was predicted by the earlier simulation, we were able to actually capture such an image showing a helical lines of magnetic forces. So jet what you are seeing is the simulation, and that is exactly resembling the real phenomena of a jet. This is a crab pulsar, the supernova remnants 1,000 years ago. And we made this movie based upon 7 still images taken during the period from November 2000 to April 2001. And pulsar wind, it affects in many ways the surrounding. And today, such an image it can be captured, and this really stunned me. So simulation and observation can now be incorporated in 4D film for the use in the field of education and research. Later, Dr. Ibi Suzaki and Dr. Emerson, I think, will give you a better account of such application. And so, visual image is indispensable for the studies of the sun. And computer simulation is also essential. And as I mentioned, the space, the universe is full of explosions and jets. And in the future, visual media is going to be even more important in our field of applications. Thank you very much.